and I let Brigitte introduce Andy.
Hello, everyone. Great to see so many of you here. I'll keep it short since we're already a little bit eating in the time Andy has for his invited talk. Many of you probably know Andy. Andy has worked on programming languages for a long time. He has been a member of our community for quite a long time. He has worked on formal methods, concurrency, cryptography, access control, and I personally have read some of his papers as a PhD student on mobile logics for the ambient calculus, which also won a distinguished paper award here at SIGPlan. And he did his PhD at Cambridge in the early 1990s. And then he's probably most well known for his work at Microsoft. And he recently, or I don't know, not so recently, started on some new adventures, essentially exploring generative AI for software development. So once we get this set up, we'll hopefully can get started. Fantastic. Thank you. It's all up to you.
Thank you, Bridget. So, are there any compiler writers in the room? Okay, I see a few hands. I can't really see very clearly. If anyone's written any part of a compiler, could you stand up? Any part of a compiler? All right, fantastic. You can sit down. You can sit down. So question, which compiler writer wrote these words? I suggest a reply to those who would like data processing people to use mathematical symbols that they make them first attempt to teach those symbols to vice presidents or a colonel or admiral. I assure you that I tried it. Which compiler writer? Grace Hopper. So Grace Hopper eventually became a very senior officer in the US Navy, a rear admiral. But she actually left university and joined a startup called Eckert Mochley that eventually became part of Remington Rand and worked on the UNIVAC computer. And her project was automatic programming. And she said, in really quite a visionary way, it's much easier for most people to write English than use symbols. So I decided data processors ought to be able to write their programs in English, and the computers would translate them into machine code. And that was the beginning of COBOL. So she had a language called Flowmatic, and she started working on that in '55. And those words were a little bit later on, but she was talking about using English as a programming language from the early '50s, like 70 years ago. Now, COBOL is an amazing accomplishment. It really transformed what was possible for data processing back in the '50s. And astonishingly, I know there's people who work at banks here or have worked at big banks, and lots of big banks are still running COBOL code in their mainframes. So it was a particular technical accomplishment that has really endured. Still, I think it falls short of Hopper's vision of English as a programming language. So fast forward 70 years, for a Scotsman like myself, this AI-generated image of the cross of St. Andrews for the city of San Francisco as a backdrop is a reminder that for the general public, the era of generative AI began on St. Andrew's Day 2022, almost 2 years ago, when ChatGPT was launched. That's when most people first heard about generative AI. Now, it's had incredible public uptake, and it's triggered intense competition in the tech industry. And I'm here to say that generative AI is making a huge difference to how people write code, and is going to empower way more people than previously could write code. And this is a keynote, so I think I'm allowed to be a little personal. And so I'm talking a bit about my personal journey. I was at Microsoft for a long time, and generative AI was part of my story at Microsoft. I'll tell you about that. And it led me to a new startup called Cogna that's in London, and we were building a new kind of compiler that goes from natural language, as Grace Hopper had envisaged, right down to machine code. I'll tell you about that too. And I've come to realize that what we've been doing is working on Grace Hopper's vision of automatic programming. So here's a sort of foundational text of the last year and a half. And this is from Andrej Karpathy. And he is a very accomplished person. He was at Tesla. I think he reported to Elon Musk at Tesla about in the mid-2010s, working on machine learning for self-driving cars. And then he moved to OpenAI and was very influential, led a lot of initiatives at OpenAI. And in January 23, about a month after ChatGPT, a month into this era, he realized that lots of people were actually able to get code by prompting ChatGPT in suitable ways. And he called out, the hottest new programming language is English. I don't think he was aware, but that really what he was doing was restating Grace Hopper's vision from 70 years previously. So the aim of my talk, tell you a bit about my personal experiences with generative AI in this direction, and hopefully get you excited to make contributions yourselves. So let me start with a bit of a prelude from the latter part of my time at Microsoft Research, and how we generated formulas from using generative AI. But first, let me remind you a bit about end-user programming. So this has been a subject of interest, I think, in the HCI community and in the parts of PL that work with HCI since '93, which is what, 30 years ago. Can I add up? Yes, 30 years ago. So this is like Bonnie Nardi is an ethnographer, and she worked at HP Labs, and she did a study of how end-user programmers about end-user programmers. An end-user programmer is someone who writes code for some sort of personal purpose, and not as part of their professional role. So probably most people in the room, the people who are compiler writers, you are not end-user programmers. You're writing code for other people to use. But a great many people, and arguably, I think, way more people are end-user programmers than are professional programmers. And the kind of people Bonnie was talking to were like accountants or doctors or salespeople who would write spreadsheet formulas in order to process data in order to get their work done. And crucially, these people, unlike us, are not really interested in programming. They could take it or leave it. What they're really trying to do is be a great doctor or be a great salesperson, and they're using code as a means to an end. I don't think she mentioned any admirals or colonels that she was addressing, but maybe some of them are end-user programmers too. So by then, there were actually lots of people writing code in spreadsheets. But I think Hopper was correct. It's really quite hard to write formulas. So let me show you this. This is what we did at MSR about 3 or 4 years ago that was published at Chi 22. And we looked at the spreadsheet table as a sort of affordance for end users to manipulate data. And one of the key things we found was that column formulas are really valuable for end users in terms of making sense of their data. So let me see. You're not going to see that. If I use this laser pointer. Okay, that's better. So there's a table, and it's quite small to read, I'm afraid, but it's got multiple columns. It's got employee names. It's got employee names, it's got buildings, it's got start dates, hard dates, and so forth. And the person here has added a couple of additional columns to make sense of it. And these are the formulas. These are the kind of things that Grace Hopper was complaining about. What does that formula mean? I mean, I'd say I'm an Excel expert, but what does this mean? Dated if, D2 today. Doesn't make any sense. It's actually date diff, and it's doing a subtraction. And this formula is figuring out in years the number of years of service this person has had. But it's pretty hard to understand. And this formula down here is finding out the surname of someone. So we did a survey and a study of how people were working with data in spreadsheets, and found these tables, first of all, do empower users to sort and filter and look at data, but so does adding additional information like that. But there's a big barrier. You have to write this formula, and it's hard to write those things. So that motivated us to see if we could apply generative AI to construct formulas. I'm getting confused with my mouse. Let's just go with this. Okay, so this slide is really just to say that amazing progress has happened. This is from March 2024, and this was a slide that Anthropic put out when they launched Claude, or the latest version of Claude, one of their very large and very powerful language models that's sort of comparable roughly to GPT-4. The rows in the table are different benchmark suites. And the one that I've highlighted is called Human Eval. And Human Eval was introduced by OpenAI, and it's a set of challenges to construct bits of Python code given short bits of documentation, like 30, 40 words, descriptions of what a Python function is to do, like maybe a Python function for the formula I just talked about. That would be the sort of thing that calculating the number of years since the start date would be like an example of the sort of thing that you see in Human Eval. And the columns in this table are for different language models, and these three here are from Anthropic, including Claude, and this is GPT-4 here, and they were very pleased that they'd done much better than GPT-4. GPT-4 was at 67% on this Human Eval data set, and they got up to 85%, which is pretty cool. And so what is well, I've said what Human Eval is, and the progress is astonishing, because GPT-3 came out around about 2020, and it solves 0% of these problems. Our team started working with GPT-3 back then and found it very exciting, but it was lots of tasks it was bad at. And then Codex, which was the model for the first version of GitHub Copilot, that was a fine-tuned version of GPT-3 that had been fine-tuned on lots and lots of code from GitHub, etc. It really bumped up to 30%, and that was in 21, which is like 3 years ago. So amazing progress from 29% up to 85% since then. Great opportunity for us. So what did we do? We wanted to generate some of those Excel formulas that you saw from language. We tried directly doing it in Codex, and in fact, we tried using GPT-3, and it wasn't very good. And that's mainly because the training set hadn't included very many Excel formulas, so the model wasn't very good at constructing them. But we thought, indirection, that's the standard trick that solves everything in computer science. So we thought, well, what if we make it generate functional Python code? And that's essentially a functional language, and we can transpile that into Excel formulas, another functional language. And this worked a treat. So here are some examples. We did a user study with our system, and we gave people a data set of sporting events and asked them to perform certain tasks. And so the gray prompt you can see there, how many times has New Orleans been a winner from participant 4, would be translated into this bit of code here, where it's constructing a new column called winner, and it's doing that by searching for this string. And notice that it's smart enough. So when we prompt it, we give it the table, we give it the column names of the table and the table itself. So it sees the example data, so it knows the kind of things that are in the data set. And so when you ask it to answer that question, there isn't literally a team called New Orleans, but there is one called New Orleans Saints. And so it's able to figure out that's the key it should put into the filter. And another example, add a column if the house satisfies all 3 requirements, has basement, been renovated, was built later than 1970 from P8. And here it's be able to generate a bit of logic from the natural language, which was great. So those are particular examples, and let me talk through the system we built. Because people always say, Andy, it's great that you can generate code, but what about hallucinations? What about errors? And this is something that we were concerned about from the very start, that we knew when we were working with Codex that every so often it would generate glitches and the code would be buggy. So we felt it was super important that if end users, particularly end users who are not programmers, are going to trust this system, they need to be able to understand what's been done for them and even to be able to correct it. So we built a system here that allows the end user to, let me just adjust my screen so I can try that. Okay, that's better. Okay, so I hope you can see this, this red, the laser pointer here. So what I'm going to walk through is how a user interface helps someone answer a question and it goes wrong and how they were able to fix it. So we've got a few columns here, and it's space. It's like names of various astronauts, including Buzz Aldrin here, and we've got the number of hours they had in space all up, and we've got what is actually a comma-separated list of missions. So this is a bit of data that you can just download from lots of, it's typical of the data you can get. And the puzzle we gave someone, so this is like from a user study, was calculate the average mission length. So they just typed that in, calculate the average mission length. And so behind the scenes, we're going to generate some Python, which is what you see down at the bottom. However, we don't show the Python to the end user because that's just going to bamboozle them, like the kernel and the general. They're not going to like the code. So instead, what we do is we try and have a bit of a narrative so that people can understand what's going on. So we start off by saying that we've created one new column, and it's called average mission length, which is actually shown there. And we show the first few rows, so 3307, and then there's this blank, 302. And the idea of this is so the user can inspect and sort of sanity check what's being produced, and so as in case they need to fix it. So they might be puzzled. Why is it that Buzz Aldrin has got a dash average mission length? And then they look further. How the system solved the task, we tell them. Well, first of all, we created a column. Then secondly, we calculated the spaceflight in hours divided by the count of the string STS from column missions. And at this point, you think, what? Why are we counting STS? And so I guess you can't see very easily, but these comma-separated, it's actually a comma-separated list, but a lot of the names of the missions have STS in them. And so what the model has done has thought was that the repetition is indicated by the occurrences of STS, when in fact it should be a comma. So Codex wasn't really great, and so it made that error. But in the user interface, no problem. The user is part of this. They want to be able to trust the outputs. They want to understand how it's been produced. So the user was able to inspect this and realize that they had to correct STS. And so if I go over here, this is on the right is the corrected thing. So actually what happened was they get to edit this output here and then click update and go. So we sort of output an explanation, and then it's round-trippable. They don't have to start from the beginning. They can update this. And then we've now asked them to divide by the count of commas. And now Buzz Aldrin has an actual average mission length correctly calculated. And we've got this correct Python down there. So that was the system we built. And there's a paper out this year that's also got a whole lot of benchmarking studies of how it works on different kind of data sets. That was at a conference earlier this year. And we had a paper about the user study at Chi last year. But to be honest, one of the really big things that happened was Copilot in Excel. So about 2 years ago, around St. Andrew's Day 2022, when ChatGPT came out, in deep secret in the halls of Microsoft, the CEO, Satya Nadella, had decided to make a big bet on generative AI and OpenAI. And he gathered his teams together and said, we've got to put generative AI, GPT-4, into all of the products. And so the Excel team was told, you've got to put GPT-4 into your product. And they had a lot of ideas, but fortunately, our team had already been working on putting precursors of GPT-4 into Excel. And so we were asked to step up and contribute it was a team effort, part of Copilot in Excel. And so it was an intense year. It was my last year at Microsoft. It was amazing. You know, we were involved, our team in Cambridge was deeply involved already with the Excel team, working with Excel in Israel and in Redmond, USA. And, you know, it just became, you know, deeper. And we were able to take what had been a sort of demo and paper at Chi and turn it into a feature that generates formulas in Excel. So that is fantastic. Now, one of the cool things, if you get something into Excel, is that other people make demos of it. So, believe it or not, maybe you don't look at this, but believe it or not, on YouTube, there are a bunch of YouTube influencers who are very popular with many millions of followers and views who make videos about Excel. And one of them is called Minda Tracy. And she made a nice video about Copilot in Excel, and she gave a demo of our feature. So she starts with her prompt, add a column that calculates the discounts as a percentage of sales. She's got a data set there of sales data, and it suggests a formula. If you click a button, it will actually explain the formula in words, which is what you see on the right hand there. And then once you're happy with it, you can click Insert. So it's not exactly the same as the concept we had at Chi, but it's very similar in that we generate the formula, we explain it in words to the user, we show how there's a sort of, you see the gray line, the gray column N is a sort of showing what it would do to the whole data set. So it's very similar. So we were very, very proud of that. And we also wrote a paper called Co-Audit for Copilots. It was super important to us that we do not just ask users to trust the output of generative AI, but nor do we just sort of blame them, saying, it's your responsibility. There might be errors here. You know, we're passing the responsibility to you. We wanted to provide tools to help people to actually interrogate the outputs of generative AI, like the ones I've shown you. So we convened a workshop within Microsoft and put out this research report about it called Co-Audit for Copilots, which is beginning a systematic study of co-audit. And co-audit is just a co-audit is just any experience like the one I showed you that lets the user sort of audit the output that has come back from generative AI. And the co is meant that it's done using sort of in collaboration, or at least using the computer as a tool to help you do the auditing. So that's my Microsoft story. Let me move on to Cogna. So about a year ago, the founders of Cogna took me to lunch, and roughly speaking, they said, Andy, what if natural language really is the new programming language? That's what we're trying to do. We're trying to build a system, a compiler, that will go from high-level descriptions, requirements in natural language, all the way to machine code. So let me tell you about this. And I need to do a little bit of a sales pitch. We are hiring. We are looking for full-time and an intern role, people to fill full-time and intern roles. So please talk to me. I'm around for the rest of the week. Or email me. I'm adg@cogna.co. OK, so what are the kind of things we do? So we're already working with multiple customers. So we've kind of, the plan always was to start with a simple system, work with customers, get real customer data of the kind of things they want to do, and then to grow. So here is this is pretty much the requirements for one of the apps that we built for one of our customers. And I've had to fictionalize it, so this isn't exactly, this is fictionalized, but this is roughly what we do. So a lot of companies have business problems where they currently have to track compliance or some sort of policy that needs to be enforced, and they have a spreadsheet where they have a spreadsheet of lots of employees, and they need to make sure they've done trainings or been to meetings or been observed or whatever, or else there's something bad might happen. They'll maybe even it might even be illegal in some circumstances. And so if it had been an airline in the US FAA has what they call currency requirements for pilots, that a pilot needs to complete a flight review with a reviewer every 24 months, and they need to perform at least 3 takeoffs and landings within the last 90 days. And if these aren't met, it's illegal for them to take off. And so the airline needs to track this. And so here I have some instructions to our system. Build an app to allow pilots to log the completed training, access flight logs showing takeoffs and landings, show a dashboard, warn if any pilots have expired currency requirements, and otherwise book pilots in for training. So that's fictionalized, but this is the kind of thing that we can take as input, and then we can build an app that runs on our site that our customer can use. So our customer ends up having a sign-on for our site, and then all their employees can use the app. So that's an example. Let me give the bigger picture, though. So this is the bigger picture of the full general-purpose software space, and it's super hard. So along this is like the breadth of software, this sort of vertical axis. All the different things you could imagine doing with software. And the horizontal axis is the kind of stages that you go through from a business problem of the sort I just described to more detailed requirements through to an actual running system that gets deployed and is maintained and has tests and has users, and you make sure the users are successful using the app. That's the sort of the horizontal axis. It's pretty hard to do everything. So let me see. So going into a bit more detail, what do we need to gather at the point of getting the business problem? Well, in my example, the business problem would be I need to keep my pilots compliant, so fairly simple to state. But generally, this is a place where you gather existing business processes, objectives, and constraints. So you really need to think in terms of how the business operates. You're working in the sort of the business domain. And then the next step is to get to solution requirements, and that's the thing I showed on the previous slide, this kind of bit of markdown saying the details of currency, and then describing at a high level the details of what the app is supposed to do. And this is where you find things like functional requirements, user flows, user stories, UI requirements. And then over on the right, a piece of solution software might be an actual pilot app, like the one that we've deployed. But in general, over here in the solution software, you've got codes, tests, and deployment. So how are people approaching this? I mean, lots of other people. Cogna is by no means the only outfit thinking about how to apply generative AI to code. So there is a lot of work on what you might call software agents. And so this picture is kind of looking at them. It's sort of, they're kind of slicing the problem vertically, if you like. So they're taking a sort of vertical slice. So these are, you might have heard of some of these, things like Devon or SWE Agent or AutoGPT. There's GitHub Copilot workspaces. There's Cursor, Composer. There's a number of tools that a professional developer can use, either to create a fresh code base or to work within an existing one. And you have some kind of chat input, and the LLM agent in the middle will think about it and will generate some code, usually edits to existing code, maybe fixing a PR or a GitHub issue, this sort of thing, and they'll generate code. So this is very broad because these techniques can apply to any kind of software. It's not tied to, say, specific business processes of the kind I was talking about. You could do Microsoft Word using these tools. You could do real-time, critical, life-critical, medical software using these kind of tools if you were careful. So that's one way to approach it. And the red here is the parts that are not being addressed. So these tools do not look at business problems, and they don't really address solution requirements, although they're starting to creep in that direction. And also, they don't address the whole life cycle of deployed software. They're really looking at generating the code, just the code, and not looking at everything else. But they are slowly creeping outwards. So that's one approach. Cogna is taking a different approach. So we're slicing the problem horizontally and looking at a very sort of thin slice, but important and valuable slice of business problems of the sort I've been talking about, where today you might have an individual who is using a spreadsheet to track some data and then needs to send some emails or make some bookings or even maybe spend some money. And often in a big firm that doesn't have an IT department that's prepared to write code for this, and so the individuals in the firm are kind of on their own and have to do it by themselves. Cogna can come in, and we will work with the company and gather the requirements, and then we have so in the middle, we understand what the end user business problem is, and then we have a platform, I'll show you a screen grab of it on the next slide, that helps us gather the business problem and the solution requirements. And then we have a compiler that goes from this high-level description in natural language plus a few other artifacts, like maybe the spreadsheet that has been provided to us, and we turn it into what would be called a custom software as a service, so like a web app that runs within our site. So the customer signs up for us, they have their account on Cogna, and the code, so both the requirements and the code end up inside this website, and it becomes an enterprise website that can be used inside their company. And our strategy is to expand outwards. We're aiming for this thin slither. At the moment, I would say this is still a work in progress, to be honest. We need more functional programmers to join us to make this more reliable. We have a system, I would say it is not 100% reliable and sometimes needs a bit of human assistance to synthesize the app. But still, we're building these apps frequently, and so we are gathering a lot of data about the kinds of things people actually want. So I think it's an amazing place to do research of this sort on compilers, because we've got a real workload that people care about. So yeah, that's what we're doing. And I think it's very much in the spirit of what Grace Hopper was saying. I decided data processors ought to be able to write their programs in English, and the computers would translate them into machine code. Okay, so here's a screen grab from our website showing how we get requirements, or the starting point of getting requirements. This is a slightly different, whimsical example we use for some internal testing in the lab, if you like, where we have a banana tracking app. And we've said our business problem is to effectively manage the number of bananas in our office. So we had a bit of a crisis with fruit flies in our startup office. And it meant it was necessary to keep track of the number of bananas and make sure we didn't get too many. So anyway, a bit whimsical. And so we've also said our pain point is we need to keep track of an inventory of the number of bananas in an office. Whenever someone eats a banana, they have to record it in a shared spreadsheet, which is kind of painful. And so the system has suggested an opportunity for a bit of software. It's going to be a software solution that empowers employees to effortlessly log their banana consumption. And it describes how the pain points have been addressed, and it gives a bit more info about various components that are being used. So this is like the system. This is going to be a video showing just a little bit of the UI. So we synthesize both Python and TypeScript, but we're going beyond like the formulas I was showing earlier. It also includes user interfaces. So we synthesize a user interface in React, including the TypeScript that does error detection and so forth. And so I just want to show you, that in action here. And before I start the clip, this is as I say, this is a whimsical example. We've got a very small database. We've got 3 offices in London, Paris, and Edinburgh, and the banana count is 10, 20, and 15. So let's just see how the error handling works. So if I click, oh, no, that isn't going to work. I need to do this. Yeah, perfect. So I'm coming in, I put in a banana count of 20, click submit, gives an error message. That's in synthesized code. And then I select London, and I select 20, and then I change it to 10. So there's currently 10 bananas in London. We click submit, it goes to 0. We try it and do it again. And we get an error message that something has gone wrong. And we debate that if you're logging you've eaten 5 bananas and they weren't in stock, maybe something is fishy, and maybe you should send an email to HR at this point. Okay, so that's where we are in Cogna. It's been super exciting. But let me zoom out a little bit just for the last part of my talk. And going back to Grace Hopper, her job title at her startup was Head of Automatic Programming. And I don't know, 50 years after that, Jim Gray, in a legendary Turing lecture from 1998 looked ahead, and he was saying lots of the grand challenges of the past, visions of Turing, visions of Babbage, have been realized. What's left to do? He was saying just at the end of the 20th century. And his last challenge, I remember reading this around about the time thinking, heck, this is impossible. But it was Grace Hopper's automatic programming, and he says it was the holy grail of programming languages and systems. And there it is, number 12. Devise a specification, language, or UI that is easy for people to express designs, like 1,000 times easier. He was a very numeric guy than code. That computers can compile and that can describe all applications, i.e. is complete. So this is the box I was showing you earlier of all possible software. And he's saying, what would be a specification, language, or UI to accomplish that? And he's calling out a lot of challenges. You need to ask about exception cases. You need to worry about incomplete specifications. And you cannot be too onerous. So he was asking a lot, and he was saying it exists in some domain-specific areas, I suppose, of very simple languages, very simple problems. And he was saying it's like an imitation game for programming staff, referencing Turing's imitation game, a kind of intelligence test for programming, or could I suppose ask, could an automatic programmer appear as if it was a human programmer, or do as well as? Anyway, that's a huge challenge, and obviously I'm going to tell you we should be using words as specification. But I would like to expand that out a little bit and show you a screen grab of a demo that blew me away when it came out, and this was from Google in February this year. So Paige Bailey is a senior person at Google, and she was blogging about her experiences using Gemini Pro, and in particular, I think it was one of the first of the models that could take a video as input. And so what she did was, she went to a website called Zillow to try and rent an apartment. And it's a kind of tedious thing to do. You go through a process once, and then you want to repeat it, and that's kind of a mess. And so she did it once and made a screen recording of it. And then she passed it over to Gemini and asked it to generate Selenium code, which is a library for Python to kind of script web browsing. And amazingly, it was able to produce working code, like about 100 lines of Python that kind of scripts what she was doing on this website. Right? It had no access. All it could see was the video. It didn't have access to the DOM or the HTML or anything like that. It was just seeing the website. And so what was she doing? She had an input, it was a screen recording. She had a natural language prompt, which was, this is a screen recording of me completing a task on my laptop. Could you please write Selenium code that would accomplish the same task? And it's come back and been able to generate it. I told you about Bonnie Nardi and end-user programming. So that was in the 90s, and at that point, people were using formulas for end-user programming in various kind of systems, including spreadsheets. And since then, in that research space, there's been a huge amount of research on what's called programming by demonstration and programming by example, where you maybe give an input and an output and ask it to generalize from that. And I think programming by demonstration has never really become very successful, in my opinion, until this. Completely astonishing. These visual LLMs can view someone's demonstration and turn it into code. So I definitely add to the inputs that we need to give for automatic programming the ability to watch demonstrations and give examples and even write drawings. There's other demos of people drawing a user interface, and then you can have systems that will take that drawing and turn it into code. So, the title of my talk, or explanation, I think our challenge is Jim Gray's reformulation of Grace Hopper's automatic programming. Devise a specification language or UI that can do those three things. And we're putting forward what I call a natural requirements hypothesis. So by natural requirements, I mean language, what I just described, language, drawings, demonstrations, spreadsheets, just sort of natural artifacts that people already use to describe their process. My hypothesis is that, or our hypothesis, given those, and generative AI, we can solve automatic programming. And so if that's true, a corollary is requirements are all you need for automatic programming. So we have a paper about this that is at a software engineering workshop that was at FSE in July. Our research vision is, phrased in terms of software engineering, was that by 2030, end users will be able to build and deploy whole apps just from natural requirements. We call this requirements-driven end-user software engineering. And I've got enough time to talk about some of the challenges, and then I will finish. So we thought there were 3 big challenges to take this forward. First of all, to get going, to assist users in expressing the requirements. Secondly, getting to the first app, because the big problem is ambiguity, as you can imagine. If we have a compiler from an ambiguous input language, we need to find some way to resolve that. And then going beyond the first app, how do we maintain these systems? So first up, how do we assist users in expressing their requirements? So this is Jacob Nielsen, who is a legend in usability. And early in this ChatGPT era, I think in spring 23, he put out a blog post and talked about the articulation barrier. It actually stopped me short, because I'd always been thinking, oh, this is amazing. If we could use words, almost all our problems have gone away, because people can write words. Well, that's not true, actually. Not everyone is good at writing words. Half of the US population struggles with literacy. There's 85% are low literacy in mid-income countries. And actually writing, which is what you need to interact well with a pure chatbot, is even harder than reading. And I think we all know that writing to get something valuable out of a chatbot is a sort of learned skill that's sort of on top of the skill of being able to write well. So first thing is, I think generative AI and ability to deal with words definitely is going to empower more users, but it's not the same as being able to empower everyone, unfortunately. So he had some suggestions for going over this, and one of his key ideas is diversified UI designs, and he means something like this. He put this up. This was already starting to happen in sort of spring, summer 23, or May 23. This is a screenshot from a website. Sorry, I've forgotten which this one is. But it's got a chat feature, but it's also got some auto-suggested possible sort of pre-canned prompts. And I think we're seeing this more and more in systems that we use, but that wasn't present in the original version of ChatGPT. And that is going to be super important for allowing people for coaxing requirements out of people. You can't just have a blank sort of text box. You need to suggest some possibilities. And then going further, I was at Cyrus Omar's talk yesterday, and he mentioned the AI Scientist, which is a paper that came out a few weeks ago that caused a lot of excitement, where this AI is able to kind of read papers, formulate research hypotheses, and then go and try them out, and then evaluate the answers, and then go and write a paper about it, sort of, including, and then it can also review itself and iterate, which is kind of mad. And I think at the moment, kind of probably irresponsible, but longer term, probably there's something to that. We were thinking there's other professions can be automated, and in terms of gathering requirements, a very successful way to gather requirement is if you kind of do an ethnography, if you sort of embed yourself within a company, understand how it works, talk to people, get a sense of the processes. Often people aren't very good at describing their own processes. They can do something, but they can't necessarily describe what they do in a kind of very coherent way, because that's not what they're trained to do. Whereas an ethnographer can go and talk to people, maybe do interviews, just observe, hang out. And so I guess we're putting forward as a research idea, which is very academic, I must admit, at the moment. We're not doing this in Cogna, because we're a startup. We can't afford this. It's quite risky. But I think this could be very powerful in the future if you could think, well, how do ethnographers operate? How do we gather user, how could those processes help gather user requirements? So I think that's an interesting direction. Progressive repair. How do we actually get from an initial set of requirements to a working system? If you think about how a professional engineering team operates. It's not, I mean, it's a kind of, I mean, there's been lots of, there's been lots of methodologies, but the gist is it's not a one-off step, gathering requirements, and then another step to do coding. It's more like a cyclic process. And I would say as we progress, we repair the requirements because they're not quite right. We need to put more detail, or actually there was a mistake. We need to fix them. Like an example was the phrase expire in the next month was in my pilot's example. What does that actually mean in the next month? Is that literally the next 30 days? Or is it by the end of October today? When exactly does the next month expire? That might need to be made clear. So this is what a team does. It repairs both requirements and code, and we need to somehow help the end user accomplish that, with a big problem being that, as I said earlier, they've got little expertise or interest in software engineering. So in the paper, there's a bunch of ideas about how we might do that, but I think this is super important, and we have not solved this problem yet. And then, the foolishness of natural language programming. Edgar Dijkstra had an opinion. He said, the naturalness with which we use our native tongues boils down to the ease with which we can use them for making statements, the nonsense of which is not obvious. Point being, unlike formal notations, natural requirements may be ambiguous or inconsistent. I worried a lot about that, but then people started to show amazing things by using NL not just to generate Python, but to generate effectively to generate verified Python. And so there's a really cool paper from UC Davis, led by Krista Lopsch and James Noble, where they took the mostly basic programming problems data set, which is similar to the human eval data set I spoke about earlier, and they took a subset, and they can use GPT-4 to generate methods in Daphne. And they did this by writing, I mean, so again, they had a problem that it wasn't very good to start off with, a bit like when we tried to generate Excel, it wasn't very good to begin with. So what they did was they took a whole lot of test examples and wrote them in Daphne, and then they feed those into GPT-4 to help it generate more. And they were able to generate verified and correctly human-evaluated Daphne methods in about 60% of the cases. And there's several papers like this. I mean, I heard about this about 6 months ago at Popple and was amazed. And since then, quite a few other similar work has been coming out. So I would say people in this room, compiler writers and verifiers in this room, I highly recommend these papers. Very interesting prospects. And nobody's done this with Lean yet, for example, or Coq or F-star. Or maybe people are starting to do it with F-star. I don't know. Anyway, I think there's a lot of hope of very interesting work to be done there. I better wrap soon. So I'll just briefly say the third point: respond to evolving requirements and environments. This is actually moving super fast. This area. I talked about some of these agents that are able to, fix GitHub issues and so forth. And there's a number of competitors at the moment. And there's now actually something called SWE Bench Verified, which is a human-validated subset of 500 problems that have been reviewed by software engineers. So it's a sort of well-documented set of GitHub issues to be fixed. And then there's a leaderboard on, I think, well, there's a leaderboard anyway. And there's I think when this started, the success rate was round about 20%. But now, yeah, maybe that was, yes, SW Agent was the paper that first proposed this data set. And they started out on success rate of about 22%. And as of last week, Amazon Q and AutoCodeRover from Singapore are neck and neck at around about 38%, getting better and better. So this is going super fast, this area. It's ICFP. On a personal note, about 32 years ago, I had my first paper at FPCA, which was the precursor of ICFP, which is like the first refereed paper out of my PhD, which I was very proud of. So I was very happy to be on the FPCA stage in Copenhagen way back then. And it's 30 years since I finished my PhD, and it was on monadic I/O in Haskell, and I was honored to be invited by Simon and Phil to join the Haskell committee to help standardize monadic I/O. That was a chance of a lifetime. And I feel, on a personal note, that joining Cogna has been a second chance in a lifetime for me. And it's open to you too, if you'd like to come and join us. What if natural language really is the new programming language? But just final words to Grace Hopper. Reflecting on her career, she thought that the most important thing she'd accomplished, other than building the compiler, she said, was training young people. They come to me, you know, and say, do you think we can do this? I say, try it. And I back them up. They need that. I keep track of them as they get older, and I stir them up at intervals so they don't forget to take chances. So I made it, okay, I think there's a huge opportunity here. I'm in a room of compiler writers. I think the spirit of, dare I say it, the spirit of Grace Hopper is with us. So if I can channel Grace Hopper, I'd say, don't forget to take your chances. Thank you.
Thank you so much for this amazing tour and talk. So I'm sure there are many questions here in the audience, so please use some of the mics. It is continued to be recorded. So we'll start with Simon over there, and we'll go back here, and then we'll go back there, and we'll switch. Go ahead.
Okay. Is this on? Yeah. So I'm Simon Peyton-Jones. Thank you, Andy, for a lovely talk.
Thank you.
I wonder, though, I'm constantly thinking, because I'm a compiler writer, I'm thinking, you know, am I now redundant? Right? Can I give a prompt to your system to say, please build me a Haskell compiler, and out will pop GHC? And so, and what's in the back of my mind is that maybe this is really good for building a large number of relatively shallow apps, and not so good for building a small number of, you know, deep, complicated programs. I mean, here at ICFP, we try as hard as we possibly can to communicate with each other in words, right? We write papers, we distill them over hours, and we still misunderstand each other with our, you know, these highly evolved brains. So I suppose my question is, how far can this go, really? I mean, do you think we will be able to make a prompt that will pop out GHC in the end?
You're putting me on the spot. Yeah, I'm an optimist. I mean, it's not like next year. It's probably not 2030. But assuming it could read the LaTeX documentation, and they're working on that, then I think long run, yeah, we'll be able to, you know, guide a system of this sort to be able to go from. In fact, yeah, let me think about it. I mean, Haskell actually does have a pretty formal specification. I mean,
we have lots of bits of formal spec, but
now that I think about it, actually, Haskell is one of the things that could be relatively easy to do.
Well, it's okay. I'm 66, so maybe I'm safe for my lifetime, but you guys are not safe then.
Maybe you can state your name briefly.
Right. Yeah, so my name is Matthias. So it's a similar question to Simon, but I feel, you know, a lot of these chat GPTs, they're very overconfident, right? They'll just tell you that something can be done, and then they'll give you a wrong answer. So I guess it's the same, you know, if you ask your Cogna to generate GHC, you know, will it say, I can't do it, or I need a research team in 5 years? Or, you know, how does it manage user expectations for things that are hard to do?
That is a really good question. And I mean, seriously, we think about this a lot. And so in the kind of analysis phase of the compiler, or in the platform itself, we try and warn users away if they seem to be asking something that is not within the sort of realm of what we can easily admit at the moment. I mean, and the kind of systems we can build are indeed very simple. And so we have some prompts to actually kind of interrogate what's been asked to sort of see if it needs something that's beyond that. But I would also point you to some really great work by Heidi Klaff, and she worked on safety at OpenAI, and she has this concept of operational design domains for safe use of generative AI. And that idea came out of self-driving cars originally, where it's one thing to allow a car to drive in the domain of a desert versus like a very busy city. So similarly, we've been thinking we should actually define different domains of operation that a system is able to work in. And then you actually hit almost a computer security problem, like you want to be careful about, you've got kind of semi-trusted code that is running, that's got access maybe to the ability to spend money for you, and you maybe need some techniques to kind of make that safe. Maybe consult the user, etc. I don't think that's a solved problem.
Okay.
All right, we'll go over the side.
Yeah. Mike Sperber, Active Group. So as a requirements engineer, you're usually asked to refer to a taxonomy of software qualities. And like the ISO 25010, for example, has, I don't know, 8, 9, or 10 columns, only one of which is the functional requirements. And part of one is the UI requirements that you listed.
Yeah.
Now, a lot of the other software qualities are usually not achieved by kind of inputting requirements and then plops out a finished piece of software. GHC is not just something that plopped out of the semantics of GHC, but it comes out of changing the software to sort of evolve it or creep towards, for example, numerical requirements such as performance. How would that work?
Sorry, I'm not quite understanding the question.
So GHC does not just it did not fall out of the functional requirements specified in the semantics, but people observed that they wanted to make it faster. And make it faster means not just generating code, it means changing the existing code, right?
Okay.
Which is the case for a lot of the requirements other than the functional requirements, right?
Oh, I see.
So the requirements, so it's not the case that the requirements are not clear. The requirements are clear, but the procedure that we humans know to achieve them is not producing code, but it is evolving code.
Okay, yes. Okay, I'm hearing the question being about how to sort of improve the performance over time. And I mean, I can speak about our current tactics, which is like, we run the software, we synthesize ourselves, and it's heavily instrumented. And so we can, look at stats on, telemetry from it running to see where there might be bottlenecks. And then that might be something where we hand fix a problem. But then it's a bit of data that we could use to do a bit more work later on to try and get the machine, or you get the AI to automatically do that kind of enhancement. So yeah, that's what we currently do. But broadly, I mean, it's a huge question. How to generate efficient code from
Thank you.
In this way. Yeah.
Ilya.
Thank you. I'm Sergey. I'm at National University of Singapore.
Hi.
Andy, thank you so much for a great and very inspiring talk. So I'm going to ask not a very technical question. So it's very easy to get excited about the applications that GPT and similar technology give us. So like you've cited the work by my colleagues at NUS who managed to do some absolutely crazy stuff with fixing GitHub issues fully automatically. And I hope I'm not the only one who is going to hold the opinion that, well, ICFP is not just the community of compiler writers. So it's a kind of a community with a very acquired taste in the problems. So we want them to be somewhat practical, but also allow us to use some mathematical rigor and have some elegance. So to the extent that I think many of us are quite snobbish in this regard. So my question is, what kind of problems, what kind of tasks in this new emerging area would appeal to the acquired taste of ICFP community, so working on these problems would be actually something respected?
You mean what would be of interest maybe to folks who don't want to do compilers but want to do verification?
Okay, so I want to prove soundness of something. I want to have a semantics that is compositional, so how can I do that here?
Well, I encourage you to look at some of the recent papers about generating verified Daphne code in response to prompts, because they're showing great progress, and I think there's a lot of scope there for. Okay, maybe that's not. I'm not sure where the proofs would come out, but there's certainly going to be a lot of scope for better and better techniques to produce verified code from prompts and explaining postconditions and preconditions back to the end user. And I'm sure there are theoretical aspects of that. But I mean, I think there's going to be a big demand for verified software, because otherwise, how can we really trust what's being produced as it gets bigger and bigger? And I think there'd be interesting theoretical questions there. But I think they would spin off from the practical challenge, and it's still quite theoretical, but the practical challenge of getting a verifier to verify the code that has come out of these systems. So I think I would encourage people to look at that, and I'm sure there'll be interesting theory questions that come out of it.
I have, and thank you so much.
Okay, thank you.
We're running a little over, so we have already 5 minutes over, so we'll take one last question, and then, you know, I'm sure Andy is around today. You can ask all the questions you like to him. So we'll go to this side for one last more.
Hi, Harry Goldstein, University of Maryland and University of Pennsylvania. I worked as a web developer for a couple of years before I started my PhD, and I thought the hard part of that job wasn't writing code. It was being the expert on the code for the business people. It was knowing how code works so that I knew what was possible to communicate that to the business. Do you think that taking that knowledgeable person out of the loop is actually a net benefit for the business? That's a very interesting question. I mean, what we're finding at the moment in Cogna is that we actually have interviews. We have people who basically are playing that kind of role, and they talk with the customer in order to help them elicit requirements, because the customer usually can't write the requirements on their own. And we're finding these conversations are very useful and insightful in unexpected ways sometimes, maybe as you're hinting. So so I think there's a lot of value from doing that, and I'm not sure how Cogna will go in the future, whether we keep doing that or whether we go towards being entirely self-serve. That's something we talk about. Maybe we'll end up doing a bit of both. So I mean, like, the AI can help in explaining what code does, but it might be a while before it has all the empathy of a human. We shall see. We'll probably end up with a mix of the two, where you have a human, but empowered by AI. A human maybe in the kind of role you're talking about, but empowered by AI is able to just work with a lot more people. So that's maybe the direction I would think we'd be going in. Cool, thank you.
All right, well, let's thank Andy for this amazing talk.